So compound interest is the topic of this video, and it's one of the core tenets of this class and of financial math as a whole. It's just very important when understanding finance and financial math to understand this idea of compound interest. So what is it? So this is the definition that I like to give to it, and it just breaks it down to its basic, most easy to understand form. That compound interest is exponential growth that occurs as interest continues to build upon itself. So let's first break apart the two words compound and interest and just take a look at each of these words individually. So compound in this case just means to build, and interest in the financial sense means extra money. And another little note for interest, extra money paid at regular intervals. So let's look a little closer at interest. And interest again is extra money paid at regular intervals. And another note you might want to make that's usually broken down into year over year intervals. So it's the most practical way to do it is just take interest in a year over year basis. So when it comes down to interest, there's really two types of interest in the real world. There's exact interest, and then there is estimated interest. So I'm going to go over each of these two types briefly so you can get a better sense of what they are. So exact interest, that is interest that is exactly the year over rate that it says. So it's exactly what it says. Estimated interest is interest that is predicted to be the year over year rate, it says. So first, let's take a look a little bit closer at exact interest. And again, that's interest that is exactly the year over year rate it says. So if it says it's 2% interest returns year over year, you will get 2% returns year over year, no less, no more. It will be exactly 2%. So let's take a look at some real world examples of things that pay exact interest. So first one is government bonds. If you ever take out a car payment loan, your car payments will be structured in exact interest payments. And if you ever buy a house using a mortgage, mortgage loans are also exact interest based payments. So all of these have exact interest rates, whatever the interest rate it says. Your payment or investment will be based on the exact number your rate was set at. So that's exact interest. Essentially, it is exactly what it says. The second type is estimated interest, and that is interest that is predicted to be the year over year rate it says. So if it says it's projecting 5% interest returns year over year, but that number is based on average estimated yearly returns, it will most likely not be 5%. Some years you will make more than 5%, and some years you're going to make less than 5%, but the average estimated return is 5%. And again, it's not always even a correct estimate in a year over year time. So there is a lot of margin for error on that. So let's take a look at some examples of estimated interest. And again, the first and probably most popular, most prominent is stock market investments. So it doesn't matter what type of stock or ETF or fund that you're investing in, whether you're buying an entire market fund like the Nasdaq or the S&P 500, or if you're buying individual stocks like Apple stock or Amazon stock, those are all going to be predicted out returns and not actual guaranteed returns. Another type is crypto investment. So if you buy Bitcoin or Ethereum or some of the lesser known cryptocurrencies, those are all based on estimated interest returns and not guaranteed returns. And another type of estimated interest returns is real estate prices. So real estate prices, they're always projected to go up or down X amount per year. And so all these three things have in common is they're all based off yearly historical averages and predictions. So they're all based off predictions and not exact guaranteed returns. So now let's move on to the question of the day. You know what the types of interest are, but again, let's get more into compound interest, and let's get into how does compound interest grow exponentially. It is the most important concept in finance, especially when it comes to investing, is how to grow this stuff exponentially and not linearly. And it all has to do with the magic of compounding. And the magic of compounding is what turns the gains into curved gains. They get more and more the longer it goes. And so, the magic of it is like you can pull a rabbit out of a hat. You can just keep creating extra dollars year over year over year through compound interest. So let's get into this magic of compounding, and we're going to go over this algorithm. It really is just an algorithm, and it's a fairly simple one, and it's only a few steps. So let's look into this algorithm and how it works. So it has to do with, first, you take the money in your account that you're starting with, and you multiply that by your interest rate. And then what that's going to equal is your new account value. And this is the part that is the magic. You then take that new account value, and that's the next thing you do is move it right here, and then you multiply that by the interest rate. And guess what that's going to give you? Your newer account value. And then you take that newer account value and you do the exact same thing, multiply it by the interest rate, and then that gives you even a newer account value. And you essentially just do this infinitely, and it grows more each time that you do it. And so this is what the magic of compounding is. It's just very simple at its core, but it just allows stuff to grow exponentially because each new account value is more than the previous one. So let's take a look at a real example with using actual numbers here. And let's say that you had $1,000 invested starting, and you're growing at, we'll say this is a guaranteed rate of 10% per year, just for the sake of making the numbers easy. So you invested $1,000 growing a rate of 10% per year, and that's exact. So it's going to be exactly 10% every year. And so let's do the first 4 years. And so we're going to have our account value, our interest rate, and then our new account value. And then this last column is going to be the money that has been added. We'll do that one at the end. So our account value, let's say we're starting off, we invested 1,000, and our interest rate, you always add it to 1. So interest rate is 10%, which would be a decimal 0.1. So what you do is you add that to 1, and then you can multiply it. So again, all you need to know, so if the interest rate was 8, it'd be 1.08. If it was 20%, it'd be 1.20. But that's how you do the interest rate calculation, is you just add the decimal of it to 1, and then you can multiply it. So we got our interest rate 1.10, and let's multiply 1,000 by 1.10. That gives us our new account value of $1,100. And so again, what that does is essentially it's like it adds 10% to our account. So now we're going to take that 1,100 and we're going to move that down to year 2, and we're going to multiply that by the same interest rate, 1.10, and now that's going to give us $1,210. And again, now we're going to do the same thing, take the 1,210 and we're going to multiply that by our interest rate, and now it's 1,331, and we're going to take that and we're going to multiply it by our interest rate, and it's going to be 1,464. So now let's look at the money that has been added each year, and you can see that it grows by a little more each year. The first year we added 100, the second year we added 110, the third year 121, and the fourth year we added 133. So instead of just adding 100 each year, it actually keeps growing more and more. But now let's flash forward. Let's go to year 19 and 20 and see what this account looks like in year 19 and 20 based off this 10% return. So by year 19, it's reached $5,560, and we're going to again multiply it by the same rate, and that's going to give us $6,116, which now we're adding 556. And now for year 20, we'll take that same 6,116, and we're going to multiply that by the interest rate of 10%, and now that's going to give us 6,727. So now we're adding $611. So if you see that money added column, that right there is exponential growth, because each year it grows by more than it did the previous year, and that's just with the same initial investment. If it was linear growth, it would be the same exact amount each year, it'd just be $100 added each year. The exponential, as you saw from year one, growing at $100 a year, to year 20 is growing now at $600 per year, and then year 21 will be more than that, and 22 will be more than 21. So that's the exponential growth, but that still is not even as crazy as it gets. The best equation is when you do the magic of compounding. So what I just showed you, the magic of the compounding plus yearly investments. That was a one-time investment that we just went over. But if you keep doing reoccurring yearly investments, what that is going to end up equaling in the long run is a lot of money. So, instead of pulling out, a few dollars here and there out of the hat, you're actually going to be pulling out stacks, and more each year. So now let's look at a very similar example, but this is going to be with yearly reoccurring investments. So you're going to invest 1,000 yearly, and it's going to be growing at that same rate of 10% per year. So the difference is that we're investing, instead of just investing 1,000 once at the beginning and just letting it sit there, we're going to be investing 1,000 every single year. So we're going to set this up in a pretty similar way. We're going to do 1, 2, 3, 4 year, and then skip to 19 and 20. And then our columns, we got previous year value, the total value, the interest rate, and the new account value, similar as in the last table. But we're going to add this column over here on the left, and that's where we're going to put our yearly reoccurring investment. So see, in the scenario, we're investing $1,000 yearly, so we're going to just invest $1,000 every single year, no matter the year. So what we're going to do with that is we're going to then add that every year to our previous year value. And so we're going to do that same process, but with the addition of adding that 1,000 each year, and we're going to see how that affects our total value right there. And again, that's going to just add way more to all the amounts. So let's start with year one, and we're going to see with how much adding this yearly investment, the reoccurring investment, changes everything. So first, let's start off. Our previous year value in year one is going to be 0, because again, it's year one. So 1,000 plus 0, the total value of the account is right now at 1,000. And now we're going to do that where we multiply it by the 10% interest rate. So it's like we're going to add 10. And that gives us our new account value of $1,100. So this is where it's going to be the same as that compounding, but just with the addition of that 1,000. So we take that new account value, put that into the previous year value. So now we're on year 2, and now we're going to add the yearly investment of 1,000 to our previous year value, and that's going to equal 2,100, and that's what we're going to take the interest rate from, that 2,100. So then we're going to multiply that and add the 10%, and that's going to give us $2,310. And now we just do this cycle forever and ever. $2,310 goes in the previous year value, and now we're going to go 1,000 plus that, and that's going to give us 3,310. Multiply it by the interest rate, gives us 3,641. And again, now you get the picture. We're going to take that, put it in the previous account value, add the 1,000, going to give us 4,641. Multiply it by the interest rate, and just keep that process going and going. But let's now skip to year 19. Let's say we've done this for 18 years, and now we're in year 19. So at this point, the value would be at $28,132. And again, in this example, this would be based off the 10% is an exact interest rate, just for the sake of easy numbers. So we take that 28,000, add our 1,000, and now we're drawing the interest from 29,132. Multiply it by that 10% increase in the interest rate, and now we're at 32,045. So now we're going to take that and put it in the previous year value column for year 20, and we're going to add 1,000 to it, and that's going to give us $33,045. take the 10% interest rate of it and add it, and it's going to give us $35,249. So look at the exponential growth in this account. So let's look at the amount the account increased from year 1 to 2. And so from year 1 to 2, there's a $1,210 increase. And now let's look at the increase from year 19 to 20. It's a $3,204 increase. So the year over year increase has almost tripled. And again, the further out you go to year 40, year 50, the wider that gap will get between year over year increase. So let's look at a real world example now of this effect of compound interest. And what we're going to do in this real world example is we're going to invest $2,500 into a general stock fund every year for 45 years. So let's say we just buy a general stock fund that what those do is they pretty much invest into the entire stock market. They buy almost shares of almost every company. And let's say that they're telling you that their estimated interest rate is a 5% interest rate gain per year. And what we're going to do is we're going to take a visual look at this exponential account growth, and it is pretty amazing to see visually. So let's take a look at that. So again, we're investing $2,500 every year for 45 years. And we're looking at an average of 5% estimated interest each year. So in here on our y-axis, we're going to have the money in our account. That's what we're measuring on the y-axis. And then the x-axis is going to be the years that we've invested. Again, year 1, halfway would be 23, and 45 would be the end. So in this, we're going to have our blue represent the amount of money we invested. And so that's going to be right there. So that's just the amount of money we're investing, the $2,500 we're investing every single year. And the red is going to be the interest gained. And this is the crazy part. It starts off so slow, but look at the end of it, how much interest you're gaining each year near the end. And this is off just an estimated 5% interest. So when you look at that, you can see that the red near the end, it looks like it's almost triple the size, maybe even a little more of the amount invested. So your interest just starts becoming an absolute behemoth near the end, or and if you went another 45 years, it'd be even more. So the yellow line here, this is going to be the average account value. So this is based off the average calculation. If you're averaging 5% per year, it would follow that line. But remember, this is a real world example. This is an estimated interest and not an exact. So the actual account value is going to be represented by this pink line, and the actual account value would look a lot more choppy than this. It's not just this perfect up and up. If you bought a 2% government bonds, it would look like this, but it would be, smaller because government bonds pay 2% interest on average. But again, if you're doing a general stock market fund, it's going to go up and down, and there's going to be years when it actually loses money. So the actual account would look like this, the pink line, where it follows the trend line of that yellow line, but it's never actually on it. Sometimes it's above it, sometimes below it, but over time it will follow the average trend line. That's what estimated interest really does. But take a look at this, and again, let's separate the interest from the amount invested. And let's just say you just never invested anything, and instead you just put that same amount into savings. So instead you're just saving $2,500 a year for 45 years. And so that's blue, all these blue lines just going to be the amount saved. So if you did 2,500 times 45, that's going to be $112,500 would be the amount that you would have saved over 45 years. Which again, that's a lot. That's nothing to scoff at. But again, look at that red, all that red that is missing. So let's go back to that real quick. And again, now we're going to do it based off the premise that we are investing $2,500 a year for 45 years, not saving it, with an average of 5% estimated interest each year. So let's bring that red back, the interest gained. And as you can see there it is again. And if you were to take the estimated and just try to take that average 5%, that would be $286,000 worth of interest. And so again, $286,750 worth of interest that you potentially missed out on. So this yellow line would be the average account value. Again, if it was exact interest, it would actually just be this exact line. It would be exactly $286,000 in interest, but it's estimated, not exact. So we'll show you the exact, but the exact value would be the 286,000 in interest plus the 112,500 saved. So the total would be $399,250 if it was exact interest. But since it's estimated, that would be our average line that we're trying to follow. And it's going to be somewhere around there, but it would not ever be exactly that much. So this pink line would be the actual account value. And this is going to be a range of values, actually. It could be a little bit less. So, if we're actually investing it, if the market had been down over this period, a little bit down, so it's doing maybe, say, 4% on average per year instead of 5%, again, it's going to be right there. Or it could do a little better, too. That's the thing. It could do better. And so that would look like this, where it's doing well and it's a little bit above that 5%. So our estimated range that we could look forward would be about 350,000 to about 450,000, somewhere in that range. Because again, if you've ever looked at a stock market graph, it absolutely does not follow just a general nice curve like that. It's always choppy, always up, always down. But it would follow that trend line to an extent. So that is everything you need to know about compound interest, the different types, how the algorithm works, and how reoccurring investments boost it. So I hope this video was able to help break it down and kind of give you that real world application of it as well, and show you the magic of compound interest, and like Einstein said, how it truly is the eighth wonder of the world. And like I end every video, have a nice day.